Alright, Andre, I am back with Sprint2 for the AABB collisions. So I am first going to play this because the last time I made this video, one of my things wasn't working. It was because it was the same color. So this is AABB on AABB. That sounds terrible, but whatever. So now that worked. So now I'm going to go to the sphere, which is on the other side. There we go. And it's going to collide. Yay! AABB collisions work with spheres and their own type. So that works. Yay. And obviously I changed my tank, and then I have a tiger on the other side. So I'm going to show you what I did. So in Collidable, obviously I made these specific changes to make it take in a collision volume, and then the set collider model then takes in a volume type, which then you can specify in the user code, and if it's a B-sphere, it makes a new B-sphere, and if it's an AABB, it makes a new collision volume AABB. So that's easy. So I'm going to go to the AABB volume now. So in here I have the intersects for a volume, AABB volume with a B-sphere, and then with another AABB. Compute data is right here in the math tools, right there. Obviously I am scanning for all of the vertices. I apply the world matrix of the model to those vertices, and then I set the min and the max of that model. Pretty simple. This debug view is for the show AABB, which I'll go to. Show AABB then takes in the collision volume. It then determines the scale by doing the max minus the min. It does the rotation, which is just identity, because we don't need to really do rotation for that. And then translation is half times the max plus the min. So pretty simple. And then I apply it and I submit it to the AABB in the visualizer. So what I changed with the visualizer, it is not making a wireframe every single frame. So it's only making it once when the visualizer starts up. And then I have added in command patterns. So in the visualizer, it is only going to be making that wireframe in its constructor, which are right here. And then I will go to the submit B-sphere, and submit ABB is the same thing. So obviously I made two collections for each type. So there's a recycled collection, and then there's a regular command collection. So let's just look at the B-sphere, for example. If the recycled collection is empty, it's going to make a new command, and if it's not empty, it's just going to recycle those commands. Pretty simple. And then the visualize all is going to go through each of those command lists. It's going to execute commands from the command pattern, and then push those into the recycled collection. And then at the end, it'll just clear that command collection. So it'll do that for the B-sphere and the AABBs. So I will then bring you over to the visualizer command pattern, which is basically the same thing as like the scene broker, but it's not actually attached to the scene broker. This is just its own thing. So I have a base class which has a set parameters and an execute, and then there's a B-sphere command, which is the derived class, and then the AABB one. So B-sphere command, its execute is just going to be calling the privately render a B-sphere. Same thing with the AABB, privately render a B-sphere, or AABB. And then going back into the visualizer, it then, where is it? Oh, it's all the way to the top. Privately render B-sphere, privately render AAB, and just renders them each to the camera. So now I will go over to the math tools, and I will do all the fun collision stuff. So AABB to AABB collisions, just basically checking to see if each of these statements is true. If one of them is false, obviously it'll return that, hey, nothing is colliding. But if they are, they are. Then we go to AABB with B-sphere, and it's just making, we make a squared radius from the sphere, and then we check the sphere's center with the AABB's min or max, depending on which, and then we just get that squared distance and we minus equal it to the power of the sphere's center minus the AABB's min or max, depending on which one we're on. So there's my work for this week. Everything is there. Obviously you saw the double dispatch stuff, which is working. So I guess I could talk about what topic I am thinking of doing. So I did a little research, and I think that I'm going to be messing with lighting. So I didn't think it was that terrible in DirectX when we were doing it. So I don't think, after looking at some of these tutorials, I don't think that they were that confusing. Especially when you have tutorial websites like this that are called Learn OpenGL, and then you have basic lighting, and it literally just talks about how to do ambient, how to do diffuse lighting, how to do normal to vectors. So yeah, I mean, lighting just seems more interesting, I guess, to do for a project. Because, everybody does sound, and sound is, I guess sound is very, important to games, but, also lighting makes it look pretty, and I like pretty things. So yeah, it also talks about specular lighting, and the different shades that we can do, and then also they have advanced lighting as well, but that's if I seriously want to get into that. So the bling, the fong, determining where your eye position is compared to the light, and all those vectors. So yeah, so I'll be looking into this more over the weekend, definitely, which means I'm going to be going into, pretty sure, Azul Core Code to see how everything is done in OpenGL, which you said isn't much different in DirectX, so we could probably figure that out. So yeah, so there is my work for this week. Thanks.